Pickup devices, like the ones we saw in the last segment, transmit an electrical signal to some type of vibration monitoring instrument. That instrument interprets the signal and provides the technician with information regarding the nature of the vibration. One type of vibration monitoring instrument is a vibration meter. As you recall, vibration meters provide a general reading of displacement, velocity, or acceleration. They normally do not provide detailed information on any of the parameters. However, vibration meters are portable, which gives the user freedom to move from one test point to another. Here's a typical vibration meter. It consists of three basic parts: a pickup, like we saw earlier, a connecting cable, and an instrument, which houses the electronic components that convert the pickup signal to a meter reading. This particular unit is battery operated and provides overall vibration readings for displacement, velocity, or acceleration. As you can see, it has a meter and several control switches. The meter itself has scales, each of which has a different range. The scale can be selected according to the amount of vibration being monitored. This switch is used to select the meter scale. There's also an on-off switch. The on-off switch can also be used when testing the batteries. This switch is used to select the parameter to be monitored, either displacement, velocity, or acceleration. There's another setting for this switch labeled SE on this unit that can be used to find faults in roller-type bearings. When the instrument is set at this position, the meter displays the vibration caused by metal-to-metal contact of the bearing components. The meter that you use may be different from the one you just saw. So before you try to use a vibration meter, make sure you're familiar with all the switches and controls. Now let's see how a vibration meter is used. When a vibration meter is used, there are a few basic steps that should be followed to ensure that the readings are accurate. One step is following both the manufacturer's specifications and your own company's procedures regarding the use of the instrument that you have. Another is checking the condition of the instrument prior to its use. The pickup, cable, and meter should be visually inspected for signs of damage. Many of these instruments are powered by batteries, which should be checked before any readings are taken. If the batteries are weak, then it's possible that the readings will not be accurate. After the batteries have been checked, the instrument can be turned on. Many meters have a keypad or switches to turn them on and select specific functions. If the instrument needs to be calibrated, then it should be done at this point. Many instrument manufacturers recommend that meters be calibrated at least once a year to ensure their accuracy. This can be done by using a calibrator, which is commonly referred to as a shaker or shaker table. A calibrator produces a vibration that has a known frequency, displacement, velocity, and acceleration. By placing the meter pickup on the shaker, a meter reading can be taken. That reading can then be checked for accuracy. Once the unit has been calibrated, the parameters can be chosen. In other words, displacement, velocity, or acceleration must be selected, depending on the situation. Then the pickup device can be attached, as we saw earlier. Next, the meter scale should be selected. As I said before, each scale has a different range. Choosing the proper scale depends on which parameter is being monitored. Many meters have a variety of settings to choose from. It's a good idea to choose the highest setting first. Then, if there's little or no needle movement, the meter should be shifted to a lower scale. The same holds true if there's too much needle movement. If the needle is too far to the right side of the scale, then a different scale will have to be chosen before an accurate reading can be taken. Once the unit has been checked and set, the machine's vibrations can be monitored. Now, once the information is collected, it can be used in a number of ways. It can be analyzed by the technician that collected it, or it can simply be given to other personnel for analysis. In many cases, the information is compared with guidelines created by trade groups, such as the American Petroleum Institute, the National Electrical Manufacturers Association, and the American National Standards Institute. These guidelines can help determine the general condition of the machine being checked, but may not identify a specific problem. Other guidelines may be available for the equipment in your plant. Some equipment manufacturers supply their own equipment condition guidelines. This information may be included in the operating and maintenance manual supplied with the equipment. It may also be available from the manufacturer on request. Another type of guideline that can be used is a vibration severity chart. A vibration severity chart is a type of graph created from thousands of vibration readings taken from different types of machines under many different conditions. While this type of chart is not a precise indicator, it does offer good general information. By plotting the readings that are taken, the overall condition of a machine can be determined. Let's take a closer look at a section of the chart. The horizontal axis represents the displacement of the vibration, expressed in mils, peak to peak. The vertical axis represents the frequency, expressed in cycles per minute. And the third set of lines represents the severity of the vibration. These lines are normally labeled as good, fair, bad, and very bad, or some similar terms. Each of these diagonal lines also has a velocity value associated with it. To use a vibration severity chart, the frequency is located on the vertical axis on the sides of the chart. A straight line is then drawn across the chart from that point. Next, the measured displacement is found on the horizontal axis at the bottom of the chart. Then a straight line is drawn up from that point. The point at which those two lines intersect will lie somewhere between two of the diagonal vibration severity lines. The area between those vibration severity lines will be marked to indicate whether the condition of the machine is good or bad. A vibration severity chart is helpful when it's used with a meter or analyzer that can be set to measure vibration amplitudes at specific frequencies. For example, the meter being used here indicates a displacement of 1.5 mils at 800 cycles per minute. When the figures are plotted on the severity chart, the lines intersect at a point that falls within the good zone. So at 800 cycles per minute, the vibration is not very severe. Another way to use the chart is by simply plotting velocity. For example, suppose the velocity of the vibration in this machine is found to be 0.1 inches per second. By using only the diagonal lines on the severity chart, we see that 0.1 inches per second falls between the fair and the slightly rough zones. Any machine that is monitored for vibration can have its own graph. That way, each time the machine is monitored, the data that's collected can be plotted on the same graph. Over a period of time, changes in vibration levels or trends may appear. These trends can help maintenance personnel detect problems and schedule maintenance. Well, we've seen how to use one type of vibration instrument, the meter. But meters can only provide general information.